Hello everyone. We have a distribution panel inside a shopping mall, and 6 three-phase air conditioners are connected to this panel to cool the entire hall. Now, let's calculate the size of the incoming cable to this panel. But there's an important detail. The panel itself is installed indoors, but the incoming cable runs from outside the building to the panel. During the summer, when the air conditioners are operating, the outdoor ambient temperature can reach 50 degrees Celsius. Each air conditioner draws approximately 8 amps. And the distance from the main distribution panel to the air conditioning panel is 25 meters. So, now that we know all the important information, let's determine the cable size step by step. First, because the cable run is relatively short, we can start with the current carrying capacity, or ampacity tables, rather than making voltage drop the main sizing factor. Now, we have 6 air conditioners, and each one draws 8 amps. So, 6 times 8 gives us 48 amps. Therefore, our starting load current is 48 amps. At this point, we go to the cable ampacity table and look for a cable that can safely carry this current. But there is one very important point we cannot ignore. The cable is exposed to an outdoor ambient temperature of 50 degrees Celsius. So we cannot simply look at the standard ampacity table and choose a cable rated for 48 amps. We also have to apply the appropriate ambient temperature correction factor. For example, under IEC 60364 guidance, the correction factor at 50 degrees Celsius depends on the cable insulation. For a PVC cable, the factor is lower than 1, which means the cable's allowable current is reduced at this high ambient temperature. And this is exactly where many cable sizing calculations go wrong. They calculate 48 amps, look at the table, choose a cable, and forget that the cable is operating in a 50-degree environment. So the real question is not simply, can this cable carry 48 amps? The real question is, can this cable still safely carry 48 amps after applying all the required correction factors? That is the point where our cable selection becomes an engineering calculation, not just a quick look at a table. Looking at the table, we go to the section for 3 and 4 core cables, because our air conditioners are 3-phase. A 10 square millimeter cable allows us to pass 60 amps through it, so we should choose this cable. No. Why? Because we still haven't considered the temperature correction factor. In other words, the 50 degrees Celsius ambient temperature reduces the cable's current carrying capacity. By referring to the ambient temperature correction table, you can see that at 50 degrees Celsius, the correction factor is 0.7. If we multiply 0.7 by the cable's rated current of 60 amps, we get 42 amps. That means, at an ambient temperature of 50 degrees Celsius, this 10 square millimeter cable can carry no more than 42 amps under these assumed conditions. So, this cable is not suitable. Then we go back to the table and choose the next cable size up, which is 16 square millimeters. This cable can carry 80 amps. If we multiply 80 by 0.7, we get 56 amps. That is higher than the total current required by our 6 air conditioners. So, a 4-core, 16 square millimeter cable is suitable for our project.